Hello and welcome to the Urbano 12 webinar. My name is Michael Vajic and I will be your host in this presentation. So today's agenda is very simple. After this very short introduction, we will have a live preview of Urbano 12, or to be more specific, of all the new features of Urbano 12, or the most important new features. So this will not be like a workflow from start to finish, but more an overview of the most important new developments that we have made in the past 2 years, let's say, that went into this version. And after the live preview, just a short talk about how to switch to Urbano 12, and then we will go, of course, to the important questions and answers. So if you want to ask us any questions, you will find the questions panel, and you can write your questions there. If you have any sort of issues, you can also use the chat panel, and we will try to assist. Regarding questions, we will of course try to answer the questions live. If not, we will do it later on by email. Okay, so what's new? A very simple question, and not such a simple answer. So Urbano 12 is a version that is very much had many user wishes included in the final version. So there's many small things, but also big things that went into this version. Also, there's a simplified installation procedure. There's of course lots work done on profiles, so profiles are more faster, they are more customizable. There has been a lot of work on data import and export. So there's new possibilities. There's new user interface. So they're simpler now. They work faster. So a lot of work there. And we also have an additional module called Urbano Collaboration. So you can, this is an add-on that you can buy for Canalis or Hydra or Ultimate. It doesn't matter. It works with everything. And this collaboration module is, of course, aimed at teams when they are collaborating on a project. And we have done some very important additions to this collaboration module. So data shortcuts, this is something similar to Civil 3D. If you are using Autodesk Civil 3D, then you have some concept what are data shortcuts, and also the possibility to store the digital terrain model in a database, which can be on the server. And this means you work just as usual, just as if you had the digital terrain model in your drawing, except you don't have it in the drawing. You have it in the database, so you can set elevation heights, you can design profiles, everything you need to do. But the DWG file stays very small, and you can have a digital terrain model with millions of points stored on a database. Also in this collaboration module is a multi-user concurrent project design, also made with a database. So again, if you have a team and they collaborate or they work on the same project, for example, one works with water and another person works with sewage, they can concurrently work on the same project design and using a database, and they don't need to exchange any kind of files or anything like this. Okay, so Now we can switch to the live presentation, and the live presentation will be done by my colleague, Mr. Ino Nemarnik, who is the development manager here at Studio Ars. So Rino, please take over.
Thank you, Michael, for your introduction. Hi and hello to everyone. My name is Rino and welcome to another Studio Ars Urbano webinar. Today's topic will be new features in Urbano 12. And in the following 1 hour of live presentation, I will show you the most important new features such as measurement units, polyline sections, new features in Canalis regarding storm drains and catchment areas, IFC 4.3, import from EPA SWM and S3 shapefiles, new features in profiles and manhole schemes, and many other. There are many other new features that I will not show today, but you can read all about them in the documents available in the materials section of GoToWebinar. So let's start with the live presentation. First, let's see what's new regarding the running of Urbano. During the installation of Urbano 12, you can now choose if you'd like to create a new CAD profile, which is the standard way, or run Urbano in any CAD profile, so on demand by running the Urbano loader from the ribbon. Also, during the installation, you can now select which language versions of Urbano you'd like to install. So as you can see on my ribbon, I installed English metric version, English Imperial version for United States, Croatian version, and Italian version. So with these icons on the ribbon, you are loading the software. And if you want to switch between different language versions while you work, you can go to Settings and to Application Language. So here you can see application language. So these are basically the translations of the software on various dialogues. And also you see language dependent files. So language dependent files are catalogs, configurations, templates, and so on. So you can even have a combination and see the software translated in one language and use the language dependent files from some other language version. Also, what is very important and also located under settings is the new option to check for updates. So if I click here, the software will go to server and check if there is a newer version available than the one we are currently working on. And it says that there are no updates for version 12. So this is very important to say that this automatic update will work for the version 12. So the version that doesn't require a new license. So when the version 12.1 or 13 is released, you will still have to download and install the installation with the regular process. But for this minor updates and bug fixes, you can get the updates directly from the internet. Okay, let's now start with the first example. It will be one water distribution network example. But before we start drawing, I will show you the new function, the new dialog for measurement units. So up until now, there was no measurement units in Urbano. So each data had its own hard-coded unit, which sometimes led to some inconsistencies because you could have in one part of the software flow data expressed in one unit, and then in some other part of the software you had that same flow data shown in some other unit. And now we decided to implement this one central place where you can define the measurement units for each group of data. On the second tab, you can define where you would like to see those units. So you can show them in data previews, in data preview headers, in property grid dialogs, and also in the labels. Here you can see all the units available in the entire software. And for each unit, you can define this suffix, which will then be seen in all these functions that you see here. On the first tab, you can see that the units are grouped into groups. So basically, you are not defining the unit for each data. You are defining the unit for the group of data. So for example, here we see lengths, elevations, depths, velocities, flows, pressure, and so on. So for now, we will leave everything as default, and later on, we will come back to this dialog. So to start drawing this water distribution network, I will go to Hydra and I will import one EPANET EMP file. So if I switch to EPANET, here is the model that we are going to import. We see that we have two water tanks, we have also two pumps and one flow control valve. And also if I zoom to this part of the network here you can see this so-called polyline links or polyline sections, which have in between the two main junctions or nodes, they have some vertices. So let's now import this to Urbano. So I selected the file. We will import the pipes to pipe catalog, but also I will write the pipe diameter to custom data 1, so we can later achieve the connection of that data with the real pipe catalog. Also, because here I have this Civil 3D DTM, I will use that DTM to automatically set the terrain elevations. So let's import, and in a matter of seconds, we get this model now in Urbano, and we can see these polyline sections as well. So if we open the data tables, and I will go with the standard selection of sections, we can see that we have this single line section and also this multi-line polyline sections. And the same data can be seen in data tables, so single line and polyline sections. Also, if I switch now to a different data table for the pipes, and if I select the entire system, here we can see that we have imported the pipes to catalog. So this is some EPANET group. We see we have no materials and all the wall thicknesses are 0, and all the diameters, so nominal inner and outer diameters, are all the same value. That is because in EPANET we only have the inner diameter data. But now if we would like to achieve the connection with the real pipe catalog, we can do that by going to Tools and binding of the data with pipe and manhole catalog. So in custom data 1, we have this inner diameter data that we can now bind with any catalog from the software. And what is great about this is that you can save these connection rules to catalog. So when I click Run, notice that now we have all the real pipes set. So you can see that we have ductile iron and also PEHD pipes, and we see the real dimensions of the pipes. Okay, let's now draw the profiles for this imported network. I will use this configuration of the profile here. I will select the entire system, which is in total 29 profiles, and let's draw them here. So now let's take a look at this longest profile. So we see that we have these two water tanks, we have a pump, and also we have this flow control valve. Let's now see how we can draw and design these polyline sections in Urbano. So to do that, I will just switch to a different layer state where I have these helping points that I will connect. So let's start the standard draw dialog. And here you can see that I will use the same Civil 3D DTM surface. We will set the pipe elevation to be on a constant depth below terrain, and I will use this pipe from the pipe catalog. The new option for drawing of polyline sections is located here. So you can choose between line, arc, and polyline. And now if I click draw, I will snap to this existing node. And now I will draw these vertices basically like I'm drawing the standard node. So with the left mouse button. And when I want to break this polyline section and draw a node, I click the right mouse button. So let's draw one more polyline like this. And with right mouse button, we are drawing the real node. So if I want to draw a single line section, I can switch here to line or just draw like this and finish drawing. And that's it. We have a single line section. Now let's see what are the editing options available for the polyline sections. So let's go to editing of the polyline sections. So we can add a vertex to the polyline. So you have to select the polyline, select the segment of the polyline, and then define the new coordinate of the vertex. Then, of course, we can delete the vertices. So select a polyline and select the vertex you would like to delete. We can, of course, move the vertex like this. And you can also convert the vertex to the node. So select a polyline, select the vertex, and the node is inserted. And we have now two sections, one polyline and one single line section. Now, if I would like to delete this node, we cannot do it with this function. We have to go to standard function for deleting of the nodes. So I will delete the node, and we have the same situation that we had when we started editing. Let's now also see how we can convert AutoCAD polylines to these polyline sections. So here we can see that we have the remaining part of this network drawn with plain AutoCAD polylines. And now I will show you how you can convert these AutoCAD polylines into Urbano polyline sections. So to do that, let's go to the conversion of CAD elements. I will use all the same options as in the previous dialog. So regarding DTM, regarding pipes, and the position below the terrain. Also, the new option to create polyline sections from polylines is located here. So we will use that option. And also I will use this layer filtering option to select just the elements on the selected layer, like this. And when we click convert, all these AutoCAD polylines will be converted to Urbano polyline sections. Let's now turn off this original AutoCAD polylines, and we can see the Urbano network. Okay, let's now draw one profile. So I will draw it for this part of the network here. Again, the same configuration, but I will use the option from node to node. And let's go from this node all up to this node here. Let's draw it and let's place it here. Now, if we take a look at the profile, we can see that we have the nodes and all the data about the nodes, but also in this orange color, we can see the vertices and their data. So we have the stations, the terrain elevations, and also pipe elevations and pipe depths in the position of the vertex. But what is important to say that this is still one pipe, because these vertices are just the places in plan where the pipe is changing direction horizontally, and vertically nothing is happening. Okay, let's now also run hydraulic calculation, but to be able to run hydraulic calculation, we have to set some water demands. Here I have for each node defined the water demand with plain AutoCAD texts. And of course, we could now go into Hydra dialog for setting of water demands and input each of this value. But I will not do that. I have here one very nice function for reading of the CAD data from the drawing. So I created one configuration to read the texts on this layer and to write this text into water demand data. So let's just run this configuration for the entire system. And we can see that we defined all the water demands from these CAD texts. Let's now turn off these texts and let's go to Hydra panel, water demands. So here we can see that we have two configurations of water demands. First, this one is the one that we imported from EPANET. And this demands one is the other configuration that we now defined. So if we go, for example, to this part of the network here you can see that we imported from plain AutoCAD texts all these values. So now we have everything ready to run hydraulic calculation. So let's calculate. And each time you click calculate in Urbano, this EMP EPANET file is created. So if you want, you can open it directly from Urbano. So here it is. This is the complete network now in EPANET. And if we zoom, for example, to this part here, you can see that again, we have these polyline sections now designed in Urbano. Let's close EPANET and let's save these results. First of all, you can see that the profiles automatically updated, showing us these piezometric lines with the values of the piezometric lines on top of the lines. Also, let's show these hydraulic calculation results in the labels. So I will apply default labels for nodes and sections. Okay, and also I will open the data tables and also go to section hydraulics. So if we take a look at these values, we can see that they are in default measurement units, but let's now change that. Let's go to settings, measurement units, and here first on the second tab, I will turn on the option to show units in data tables and also to show units in labels. I will not change these suffixes, but let's change some unit for the group. So for example, I would like to change the dimension group for pipes and manholes from millimeters to meters. And also I will change flow data for water systems from liters per second to liter per minute. And also let's change the pressure from meter of water level to bar. Let's click OK, and let's just redraw the labels, refresh the labels. And now notice that in the data table, the suffixes automatically appeared. And also you can see both in the labels and in the data table that now we have the pipe diameters shown in meters. You have the flow data and water demand data shown in liters per minute. And also we have the pressure data shown in bars. So now you have one central place where you can control the units and these suffixes. But be careful, if you decide to use these suffixes from this central place, then make sure to have these suffixes cleared in the configurations of the labels and data tables, because if you have them in both places, then you might end up with double suffixes. Okay, so that's it regarding this first example. And let's now switch to something different. And that is the new features in Canalis regarding the storm drains and catchment areas. So here we have one very nice, relatively small storm network. And if we take a look at plan, you can see that the system is completely defined. We have pipes and manholes, and also in the profiles, we can see that we have all the elevations set. So the first thing that we are going to do here is draw storm drains. And to do that, I will again switch this layer state, because here I have, with plain AutoCAD lines, drawn all the positions according to this project of the storm drains. And now we are going to convert these plain AutoCAD lines to Urbano storm drains. Okay, let's go to Draw, House Connections and Drains. From the drop-down list, I will select Drains. We will use the digital terrain model. We will set PEHD pipe of 250 millimeters, and I will set a constant slope for all the drains of 20 pro-miles towards the main pipe. What is new in this dialog is that you can now also set the manhole in the drain node. So we will select this storm drain manhole, 500 millimeters, and also you can define the manhole depth below the pipe for the sedimentation purposes. Again, I will use this layer filtering option to select just the layers on the selected layer, like this. And now when we click Draw, all these plain AutoCAD lines will be converted to Urbano drains. So let's turn off now this layer containing the original lines, and you can see that we successfully drawn 31 drains, and each drain has the manhole defined in the starting node. Okay, let's now draw the profiles for these storm drains, and I will use a little bit bigger scale, 100 to 100. I will select all the subsystem elements, which are the drains. I will set the row and column spacing to 20, and let's draw these profiles here. Additionally, I will draw one more profile using this smaller scale, 1000 to 100, and I will use the option from node to node. So let's go from this first drain all through the main system to the last node, which is set as outfall. Okay, let's click draw and let's place this profile here. Let's now take a look at these profiles, and you can see that we have automatically set the manhole into the drain node, and you can see that for each of these profile, for each drain we have a constant pipe slope of 20 promiles. Now I would like to show you the function for editing of the house connections and drains. And for example, I would like to edit these two drains, so this one and also this one. We see that this pipe slope is maybe too big for this drain. So let's go to edit house connection and drains, and I will select these two, so this one and this one here. And now I would like to reduce the slope from 20 promiles to 10 promiles. And when I click apply, notice how the graphics and the data will automatically update in the profile. And now when I select multiple elements, I will select all subsystem elements. Notice that now for the slope, we have that the value is varies. So this is very important new feature for editing of house connections and drains. Before, this dialog was always showing you the last edited or the last drawn element and its properties. And it was very hard to edit multiple elements at once. Now, when the value is set to varies and you change something else, the values that are set to varies will not change. Okay, let's now close this and let's now draw the catchment areas. So again, I will switch the layer states. And here I have the positions of these catchment areas. And if I select here this, you will notice that this is a plain AutoCAD polyline. And now I will show you how you can convert these polylines into Urbano catchment areas. So let's go to Canalis panel and let's go to function for define catchment areas. I will select the entire network. I will select the layer containing those polylines. It can also be closed lines forming a closed polygon. And also I will define the runoff coefficient. You can define runoff coefficient numerically, or you can set the cover type. I will say that the cover is asphalt with the runoff coefficient of 0.9. And now I will show you the new option, which is called automatic. And this function checks whether a node, it can be any type or just drain. And I will select this checkbox to select only drains. So the function checks if a drain is located within a closed area. And if it is, it assigns these areas to the node outlets section. So this is exactly the situation that we have here. So when I click automatic, and when I save this, notice that we now have all the catchment areas defined automatically with just one click of a mouse. So if I now open the data tables and switch to data table for catchment areas, and if I select a catchment area selection, notice that now we successfully defined all these catchment areas for these drains. Okay, so now that we defined the catchment areas, let's also calculate the flows. Let's go to flow calculation, and we will do one simple rational method calculation. So CIA method with the constant rainfall intensity. Let's click save, and notice that for the main pipes, we have the own flow calculated as 0. And that is because we defined the catchment areas for the subsystem elements, for the drains. So if I select now all the subsystem elements, we see that we have the rain flows, the own flows calculated for each drain. And now if we go to calculation of transit and total flows, of course, we can see that the software calculated transit and total flows for the entire network, including the main pipes. So now that the flows are set, let's also go to hydraulic calculation and let's run pipe sizing with the PEHD pipes. Let's click calculate and let's save the results. You can see that the software calculated all the hydraulic calculation values. And also if we sort the data by diameter, we can see that the software increased the pipes on the 4 last sections, which can be seen, of course, in the data table, but also from the plan, we can see that the software automatically updated the labels, the plan styles, and also the profiles. Let's now also do a hydraulic calculation according to SWMM. So to do that, we have to first set some data. So let's go to subcatchments dialog. So this is a dialog where you can see all the Urbano catchment areas and all the SWMM parameters. So I will select all the catchment areas and I will set the same rain gauge. So I will also show you this rain gauge. So I previously created one rain gauge with the rain format set to intensity, time interval set to 5 minutes, and I have one time series for this area for 5 years return period. So basically we have now everything to go and run hydraulic calculation according to SWMM. So let's do it. If we go to options, you can see that we will do a dynamic wave calculation with the analysis time of 2 hours and reporting step of 1 minute. So let's calculate and let's save the results. So if we go to 5 minutes of simulation and apply this time, we can see that everything is 0 because the rain is just starting. But if we go to 6 minutes and apply time, you can see that the water is starting to rise in the drain. At 7 minutes, you can see that the water is starting to spill into the main pipe. And at 10 minutes, we can see how the water is flowing through the main pipes. At 20 minutes, we have the peak flow. So let's click close. And you can analyze and check all these water levels filling the pipes and manholes. Okay, so this is it about the flow calculation and hydraulic calculation. And let's now switch to something different, and that is the manhole schemes. So the manhole schemes are improved a lot. So if you go to create a new configuration, here you can see that we removed a lot of unnecessary options and parameters without losing any of the functionality. And also you can notice that we significantly improved the defaults. So now you can basically just create the default configuration. You can maybe change some colors or data. And when you go to drawing, I will draw all the node schemes. So 59 schemes with just one click of a mouse for all the manholes and all the drains. And here it is how it looks like. So this is basically a default configuration. You can see all the data, and also you can see the new format of the data table, which is now exactly the same as the one in the manhole report to Excel. So you can see that you have the outlet section, all the inlet sections, you see the names and nominal diameters or any other data about the pipes, you see angle from the outlet, pipe slopes, and invert elevations in that manhole. Let's now focus just on one manhole, and I will draw one additional manhole scheme for this node here. And let's draw the scheme here. So before, you could not define which pipes you would like to see in longitudinal section and which pipes you would like to see in cross section. So the software would always take it by randomly. And now we define some rules. First rule, which is most important, the main array, so the pipes that has the same array name, will always be shown in the longitudinal section, and other pipes will always be shown in the cross section. But even if you have all the sections with different array names, of course, the best way would be to just connect the main array sections. But if you don't do that, the program will still have some rules. So it will always go with the biggest pipes and the first biggest outlet diameter, or if this rule cannot be satisfied, it will go with the invert elevations that are same or close, or it will go with the lowest deflection angle. But even then, if you don't quite get the solution that you would expect, there is a interactive function, so manhole scheme section selection, where you can select a manhole scheme and manually change which section is the inlet section. So let's change this from 7A to 13A to 12A to 13A. And for outlet section, we will leave this one that is already set. So let's click apply. And let's redraw these manhole schemes. And now you can see that the data is changed. Okay, that's it regarding the manhole schemes. Let's now talk about IFC 4.3 export. So if we go to BIM panel and if we go to IFC export, you will notice first that we have some user dialog changes, so user interface changes. First thing that pops out is this little star warnings that says that the model is not georeferenced, that the coordinate system is not defined. So for IFC 4.3, coordinate system is very important. So let's first set the coordinate system for this model. To do that, we have to go to system settings. And here I will set the coordinate system to be Balkan Zone 5, which is the old Croatian coordinate system, which is for this area here. Let's click OK. And let's now go back to BIM panel, back to IFC export. Now you can see that there is no more warning regarding the coordinate system. Here you can see that previously I already defined the data or groups of data that I would like to export. And also I defined the file path. Of course, you can select any file path on your local computer or somewhere on the network. But here I decided to export the file directly to Autodesk Construction Cloud using the Autodesk Desktop Connector functionality. Also, what is new is this IFC base point. So you can select the IFC base point, but even if you don't select it, the program will take the coordinate of some node and set this base point by itself. Because if you set this base point somewhere very far away from the system, in the softwares like Navisworks, Revit, BIM 360, and so on, the model could look distorted because of the high coordinates. So it is always recommended to set this IFC base point somewhere close to your model. And like I said, if you don't set it, the software will do it for you. So I will select this coordinate of this node here. And also what is new, you can see that now you can also define the Z coordinate, which is very important if you want to merge this model with some other model in Revit. So now that we set up everything, let's click export. And we have to wait a few seconds for this model to be exported and also to be uploaded to Autodesk Construction Cloud. So now the file is exported. Let's click OK. Let's close this dialog and let's go to my folder, my Autodesk Construction Cloud folder on my computer. And now you can see that the model is successfully uploaded. So let's close this folder and let's go directly to Autodesk Construction Cloud in my browser, internet browser. And here you can see this is the Civil 3D DTM surface of this roundabout and its connecting roads. And if I turn off the visibility of this DTM, you can see the Urbano pipes, manholes, and these storm drains. And of course, if I select a pipe or any element, you can see in the properties dialog that you have all the data that we decided to export from Urbano, such as geometry data group, sewage hydraulic data group, and so on. Okay, let's now close Autodesk Construction Cloud, and let's now switch again to a different drawing, where I will show you one very important new feature, which is import from SWMM IMP files. If I go to SWMM, here you can see one very nice model. It is completely defined. You can see the nodes, you can see the pipes, you can see also the catchment areas, and the rain gauge with the rain data defined. And also here you can see the one outfall set in the last node of the system. Let's close EPA-SWM and let's go to Canalis panel, import EPA-SWM IMP file. I selected the file. We will import the pipes to catalog, and also I will write the pipe diameter data to custom data one. So if you want, you can later achieve that binding with the real pipe catalog like I showed you in the first example. Now here in this drawing, I don't have the DTM surface. So we will use the option to set terrain elevations from EPA-SWM. As you know, in EPA-SWM, there is no data for the terrain elevation, but we have the data about the manhole invert elevation, so bottom of the manhole, and also we have the maximum depth of the manhole, and by adding these two values, we can get the terrain elevation. So we will use this option, and let's click import. So now you can see that import is very fast. We can also label the imported nodes and sections with the default labels. And also let's label the catchment areas as well. Now let's check what we imported. So you can see that we have all the data about the catchment areas. We have all the data about the pipes and the manholes. And also if we go to the last node of the system, we will see that we have one outfall defined here. So let's now draw the profiles. I will use this profile configuration here. I will select the entire network, which is in total 85 profiles. Let's click draw and let's place these profiles here. Additionally, I would like to draw one more profile, but using the option from node to node. And let's go from this node that is furthest away from the outfall all through the outfall. Let's click draw and let's place this profile here. Now let's take a look at the profiles. You can see that we have all the data defined, and also we can see these pipes and manholes that came from EPA-SWM. So as you can see, all the pipes has just its inner diameter because that's the only data that is available in EPA-SWM. But now if you would like to get the real pipe diameters, you can use that binding of the data with the catalog that I showed you in the first example, but I will not do that again. Let's see what else did we import from EPA-SWM. So if we go back to Canalis panel, and if we go to rain gauges, you can see that we imported one rain gauge with time interval set to 5 minutes. And you can see that we have the time series also set. So if we go to catalog of curves, time series, and time patterns, we can see this time series, which is created for 40 minutes of the rain with the constant rainfall intensity of 140 liters per second per hectare. Also, if we go to sub-catchments dialog, here you can see all the catchment areas, and all of them has the same rain gauge set. So basically we have everything ready to run the hydraulic calculation according to EPA-SWM. And if we go to options dialog, you can see that we also imported the options from SWM. So we will do a hydraulic calculation according to dynamic wave equation. Analysis time will be 2 hours and reporting step will be 1 minute. So let's click calculate and let's save these results. Now you can see that we have 120 sets of results, and always when I have so many results, I like to first go to preview by object and then select some object. For example, I will select the last section of this system here, and now I will sort it by flows, and we can get for that section what is the peak flow time. So the peak flow time is 46 minutes. So I will now select that time of the simulation, 46 minutes, and I will apply those times to the model. So now we will see all the results for that peak flow in the model, so in the labels, in the data tables, and also in the profiles. And we can see this water levels in the pipes and also in the manholes. So that would be it regarding the import from SWMM and also hydraulic calculation in Urbano Canalis. And let's now switch to the final example today, where I will show you the new features regarding the S3 shapefile import and also what's new regarding the profiles. So if we go to import function, you can see that we divided this function into basically three dialogues. One is S3 shapefile import. The second one is SQL databases import. And the third one is text file import. Here we will use the shape import. First thing that you can see is that now we have only one configuration that you have to create. So you can simultaneously import multiple shape files. So let's go to my folder where I have these shape files, and all you have to do is just drag and drop them on the dialog. So the dialog is intelligent to know which files are for the sections and which files are for the nodes. And you can see that you can simultaneously import multiple files, for example, for the nodes. And for all the elements inside one shape files, you can automatically set the node type and the node equipment. So for the outfalls, I will set that they are outfalls. Regarding the data, you can use the new quick import option to import all the data from the shapefile as user data, or you can now bind the data from shapefile to Urbano, which I will do now. So the label of the section will be the section name, starting invert elevation will be starting invert elevation, and ending invert elevation will be ending invert elevation. So the diameter data, we will write it as custom data 1, so we can later achieve the connection with the catalog. And also here we can see that we have the profile name data, which we will import as Urbano array name, so we can later draw the profiles easily according to that data. So bind. Regarding the data for the nodes, you can see that we have no data about the manholes, but let's bind what we can. So the node label will be name, the ground elevation will be terrain elevation, and that's it. Now, before we go to import, we can go to temporary preview and see how will the network look like when we imported it. So if we are satisfied, we can go to import, and in a matter of seconds, we will get this network, which is approximately 40 kilometers, imported into Urbano. So now, if we take a look at the plan, you can see that we have the nodes and the sections, but we don't have the pipes defined yet. We have to bind the data with the catalog. Before we do that, let's draw a few profiles. And I will draw the profiles according to arrays, but I will not draw the entire network. I will draw just the three main arrays, the three biggest arrays, like this. And I will put those profiles like this, vertically, one below the other. And now, if we take a look at the profiles, we can see what we already knew, that we don't have the pipes and the manholes. So let's first do that. Let's again go to that function for binding of the data with the catalog. And if we check the custom data 1, we have the data about diameter. It would be good that we have some data about the pipe material and wall thickness and so on, but I know that these data are for the concrete pipes, so you can select from pipe catalog that pipe group, you can bind it, you can save the rules to catalog, and when you click run, we will get all the pipes defined for the entire network. We didn't have any data regarding the manholes in the shapefile, but if we did, we could bind it the same way like we did it for the pipes. Because we don't have any data about the manholes, I will just set them with the function for setting manholes, and I will set for the entire network this cylindrical structure 1200 millimeters. Let's click save. And now you can see that we have the manholes set in the profiles, and also the plan style also automatically updated, showing us the dimensions of the manholes. Let's also label the nodes and sections with the default labels. And I like to use this type of the labels where we have this invert elevations written next to the pipe. So now that the whole model is imported, let's check what are the new features regarding the profiles in Urbano 12. First thing that we see in this profile is that because of the very deep manholes, this bottom of the manholes are practically glued to the data table. So let's first change that. Of course, what you can do, you can go to Profile Configuration and edit this reference elevation data. But what would that do? That would change the reference elevation for all the profiles that are drawn with that configuration. And that's why we added a new possibility, which is located under Tools for Longitudinal Section. You can set the reference terrain elevation for just one or for multiple profiles. So I will override this reference elevation from 188 to, for example, 186 meters. So let's click Save and notice that now this data changed, but other profiles did not change. So this is saved just for this profile. So if you delete it and draw it again, this data will be reset. Let's now see what else is new regarding the editing of profile configuration. So here we have a lot of new features, so I will show you just the most important ones. Let's go to editing of this configuration. And first thing that I would like to tell you is that this interactive select button is significantly improved, and now it works with all the elements of any profile. So if you just pick somewhere, for example, on this terrain line, the software will take you where this data can be changed. And let's now change the terrain color. I will change it from green to, for example, now you can see that, and this is not just in the profiles, this is now available in the entire software, also for the plan styles, for the Urbano layers, and so on. You can not just choose the AutoCAD index color from 0 to 256, you can also go with the true colors and precisely define the RGB color. So let's, for example, use this brown color. Let's click OK, and let's apply this to the drawing. Also, regarding the colors, you can now set that the color for the pipes, manholes, and open channels is taken directly from plan. So for the pipes, we will not use these colors. I will change the pipe color mode from custom to automatic. And also I will do the same for the manholes. And now when you click apply, the colors will change to those colors defined in the plan view. So this is very important because if you change something in the plan, some colors or the colors of the layers, and you just redraw the profiles, all the colors will automatically update in the profiles as well. Let's see what are the new features regarding the labels in the profiles. So first thing, that if you check here in the list of components, you will not see the decorations anymore. That is because we just transferred its features to some other components. So if we go to node equipment, now you can see that the node decorations are located here. If we go to intersections, you can see that the system intersection decoration blocks are now located under the intersection labels. And also for the lateral inlets and subsystem connections, the decorations are now located under the labels of the lateral inlets and subsystem connections, which makes sense because now you can use the new option to position these decoration blocks to be next to the label. So now if you click apply, and here I use these blocks, which tells me which lateral inlet is on the left or on the right side of the main pipe. And now you can see that these labels are basically connected to the decoration blocks. Also, let's check what is new regarding the node or manhole labels. So before, you had to define these block labels here in the catalog, and it was a little bit hard because you always had to create a block, and then you had to go to the function for setting of the manholes and then select the manholes and apply the label. Now it is very easy. So this is now part of the profile configuration. So you can just include this in drawing, and this, if this option is turned on, you will always in all of your profiles see those labels. So you don't have to set it. It's already part of the profile. So also you can include it for all the nodes or just the manholes. And also it doesn't have to be just a block label anymore. Of course, it can be a block. You can see these are the default blocks that you used to define in the catalog. But like I said, you can just switch to text label and very easily just select the data, define the color, the size, the style. You can also define a frame, and when you click apply, the texts will automatically appear. Notice that the labels automatically moved one from another, and it's not just the texts or labels of the same type. Now this overlapping analysis works with all of the label types in the profiles. So manhole labels, lateral inlets labels, and also intersection labels. Okay, let's now see probably the most important new feature regarding the profile editing, and that is the possibility to group the components into a group. So let's group this invert and trench data to be in one group. So I will select all this invert trench data and just click on this group icon. For the text name, I will write invert trench data. I will say that this text is vertical, and when I click apply, you can see that this is now part of one group. Also, you can put a group inside of a group, so let's do that as well. Here I will call it invert data. Also, I will say that the texts are vertical, and when you click apply, now we have group inside of a group. Let's now check some smaller details. So for example, now you can filter out the small angles. So this is for horizontal and vertical angles as well. So if you don't like to see these very small angles, you can just say here, don't show angles smaller than, for example, 2 degrees. And when you click apply, you will not see those small angles anymore. And the last small feature is regarding this length slope data. So now you can place these texts to be aligned with the slope line on some offset. And when you click OK or apply, you will notice that now these texts are aligned, which is very important for very short sections, because these texts for very short sections could overlap. And now using these options, the text will never overlap, or almost never. Okay, let's now see these new features in Urbano 12 if I just change the profile configuration. So I will select this profile here, and I will change its configuration to this one, which I prepared earlier using all the new features from Urbano 12. And here you can see that I used the RGB colors. I grouped this data for the trench and invert, and also for hydraulic data. And also here you can see these new features regarding the labels. And it is important to say that this label overlapping will also work for the labels that are placed next to the pipe, and you will get these leader lines. Also, I would like to show you one additional configuration. This is configuration created by our users from Greece. This is one very nice configuration, and these users already started using the new features of Urbano 12, and they grouped their data into these very nice groups. And also you can see these new features for the labels with the blocks. Okay, now I would like to show you one also new very important feature, and to show you that I will again switch the profile configuration to this one here. This is the configuration from our users from Italy, and they like to use this so-called data on stations. So we have the stations, the terrain elevations, the invert elevations, and the trench depths, and they are shown in the nodes, but also every n meters along the profile. And before, in order to show the data every n meters, you had to draw these auxiliary helping elements, helping vertical lines. And now you don't have to do that anymore, because if you go now to editing of the configuration, you will find the new component which is called permanent auxiliary elements, or basically auxiliary elements on the level of the configuration. So if you just turn on this option, and then you can define what types of auxiliary elements you would like to see. For example, let's turn on the terrain parallels, and let's draw them 1 meter and 4.5 meters below terrain. Let's click apply, and now you have these polylines, these terrain parallels, and this is the part of the profile. So they will automatically appear in all the profiles which are drawn with this configuration. And even when you are drawing the new profiles and this option is turned on, you will by default immediately see these polylines. So let's turn off the terrain parallels, and let's show the invert parallel 1 meter below the invert. Let's click apply, and here it is. But what is most important are these horizontal and vertical lines. So let's draw horizontal line each 2 meters and vertical line each 10 meters along the profile. And now when I click OK, notice that this grid automatically appeared, but it is not just a grid. Now you see that we have the data each 10 meters of the profile. And like I said, now if I draw the profiles with this configuration for the entire system, we will immediately see the data each 10 meters. Okay, let's now delete these 3 profiles, and let's draw the profiles for the entire network. I will use this configuration, which I prepared for the version 12. I will select the entire network, which is in total 209 profiles. Let's click draw, and let's place them here. So now we have to wait 10 to 50 seconds depending on the speed of your computer, but it's logical to wait this amount of time for 209 profiles. And this is now done. Let's take a look, and we can see that this is the configuration that I previously showed. And now I would like to show you the biggest feature regarding the profiles in Urbano 12, and that is the possibility to turn off the automatic redraw of the profiles. So to show you that, I will split my screen so we can simultaneously see both plan and profile. So you know that in Urbano we have the dynamic model, which means that, for example, if you do some change in plan, for example, I will move this node here, notice on the right that the profile will automatically update. And you have to wait a second or two to apply that changes. For example, if you have very long profiles or very detailed profiles, you can notice this delay. But if you don't want to wait anything, now you can turn off the automatic redrawing of the profiles. And now if I go to move node, notice that the profiles on the right will not update automatically and the moving works faster. And if we now switch to the right part of the screen, you can see that now the frame of this profile is orange. And that means that this profile is not up to date. So if we go to Profile Manager, and if we switch to profile that needs update, we can see that we have 2 orange profiles. So what does that mean, that the profile is not up to date? So for example, if we now would like to go to draw pipe invert or edit pipe invert directly in the profiles, the software will not allow you to select and edit that profile because it's not up to date. If you go to this one, which is green, of course you can draw or edit the pipe invert directly in the profile. So why is this, and when is this very important? So if you're going to make some modifications and some big modifications in plan, and you don't want to always update all the profiles, now you can turn this option off. And for example, let's go to input trenches, and I will set for the entire network the single trench with 90-degree angles. And it is done with just 1 second. And all the thing that happened is just that the profile frame changed its color. So let's now go again to input data, the, let's say, upper layers, and let's say 15 centimeters of asphalt. Again, save, and it's done. Let's also go to Canalis panel. let's go to flow calculation. And because this is a sanitary system, let's use percent calculation. Let's set 25,000 people. Let's save and calculate flows. And let's now run hydraulic calculation according to SWMM. So like I said, this is a sanitary system. So I will use the flows calculated with Canalys and write them to dry weather scenario. Let's click calculate. Let's save the results. And now when I did all the modifications that I wanted to do, now I will redraw the profiles. So now I will have to wait this 10 to 15 seconds, but I have to wait it just once and not after the each command that I did. So setting of the trenches, setting of the upper layers, setting of the flow calculation, hydraulic calculation. So this is now done. And now if we zoom to profile, you can see that all the profiles are green, and we see all the data about the trenches and all the data about hydraulic calculation. And also if we go to the graphical part, we can see the water levels and this sand bedding of the trenches. Okay, so this would be it regarding the main presentation part. And now just for the last thing, I would like to show you one very quick PowerPoint about the new module in Urbano, which is called Urbano Collaboration. So this is not part of your standard license of the Urbano Ultimate. You have to buy it. It's a separate license. And this is basically a module that consists of three main functionalities. So the first functionality is data shortcut. It's a very similar workflow as Civil 3D data shortcuts, but it's a completely different technology. So basically with it, you can create data shortcuts by basically exporting systems and DTM surfaces to some project folders that are created by the software. And those projects can be on your local computer or somewhere on the network. And then you or some other users can import these systems and DTM surfaces to their drawing as references. And of course, if the original drawings are modified, they can update those systems in their drawing. Also, you can promote these systems to real systems within your drawing, and this will break the connection to the source file. Or of course, you can remove those references from your drawing. What is very important to say that these systems that are imported as references are locked for editing. So you cannot draw new elements in that system, and you cannot modify the existing geometry or data. But of course, functions that don't modify the elements are still available. So you can use the data tables, labels, profiles, thematic maps, you can do queries, markings, you can do cross sections, you can draw the manhole schemes, you can create various reports like excavation report, you can change plan styles, you can run intersection analysis or clash analysis, and so on. The second functionality is called Terraform Server. And with this functionality, you can upload the DTM surfaces to a PostgreSQL server and use those surfaces directly from the server without having them in your drawing. And this enables you to work with extremely large, huge DTM surfaces containing, let's say, tens of millions of points. And these surfaces that are stored on the server can be used just like any local surface, but your drawing, your DVG file is significantly smaller because you don't have those surfaces in your drawing. What is very important to say that it works both for Terraform and Civil 3D surfaces. And of course, if you need, you can import the entire surface or just some parts of it locally into your drawing, again, either as a Terraform or Civil 3D surface. And the last functionality is multi-user environment, which again works through a PostgreSQL database. This is very similar functionality to data shortcut, but it is a let's say, one level above, because you have to create a database, you have to log in using your username and password, you have to define users with different roles and permissions, you have to create projects and then assign users to those projects, and so on. But the point is that multiple users can work on the same project simultaneously. They can exchange messages, they can upload and download changes done on the project. They can receive notifications like you can see on the picture on the right. They can receive these notifications about the changes in the project made by other project members. And that's it for today. I hope you liked this, what you saw today. I hope you would like to try it and test it on your projects. And now, before we go to Q&A, I will give a final word back to Michael. Thank you all.